Good morning, students. In this section, we are going to study how to convert one system of units to another. They will be giving a length in centimeter or millimeter or micrometer, like that. Whenever we do the calculations in physics, we have to convert all the units to SI system. The question can be asked in any different system of units, but you have to convert everything into SI system, and only after converting you should be able to do the numerical. So in this table I am just giving you how to convert one quantities to another, one system of units to another. So you have to multiply with these powers written on the board. So let us see one by one. First we are doing the multiples, and then later on we will do the submultiples. First one, deca. The symbol is dA and the multiple is 10 raised to 1. That means to convert decameter to meter. Meter is the SI unit, you know. So to convert decameter to meter, what should you do? Multiply with 10 raised to 1. The next is hecto. The symbol is H and multiple is 10 raised to 2. Third is kilo. The symbol is K and the multiple is 10 raised to 3. Then comes mega. Symbol is capital letter M and the multiple is 10 raised to 6. Then comes giga. Capital G, the multiple is 10 raised to 9. You have heard this term everywhere. The hard disk capacity. The capacity of hard disk is written as 500 GB. So GB, so giga for 10 raised to 9. So that is how you should convert. Now the processor speed, microprocessor's speed and all, they will be given in gigahertz. So if I say 1 gigahertz, it means 10 raised to 9 hertz. Then comes tera. Tera is capital T, 10 raised to 12. Then comes peta, capital P, 10 raised to 15. And the last one is exa, 10 raised to 18. These are the higher units. So you can convert by multiplying with these powers. Now let us see the submultiples. First one is deci. Small letter d, 10 raised to minus 1. You have to be careful. Wherever I have written small letters, you should also write small letter, and wherever I have written capital, it should be capital. Otherwise, we will read it in a different manner. For example, if you are writing capital M, it is mega, but if you write small letter m, it is milli. So that kind of change will be there everywhere. So make sure that you put capital for capital letter and small for small letter. So centi, 10 raised to minus 2. Milli, 10 raised to minus 3. So example, to convert millimeter to meter, multiply with 10 raised to minus 3. The fourth one is micro. The letter is mu, M-U, mu. It is 10 raised to minus 6. Then comes nano, 10 raised to minus 9. So as we move down, we are going to the smaller section of the units. In this table, as we move down, we are going to the higher units. In this table, we are moving to the lower units, smaller units. Pico, small letter P. It is 10 raised to minus 12. Then Fermi, small letter F. It is 10 raised to minus 15. This can be also known as femto. Fermi or femto, 10 raised to minus 15. And the last one is atto, 10 raised to minus 18. You have to study this full conversion table by heart, because this is applicable not only in 11th but also in 12th, and when you go for engineering, this table is a must. If you don't know conversion, you can't touch any physics numerical. So learn this properly. Let us see certain examples. See, I have written mega ohm. So how will you convert? You already know ohm is the SI unit of what? Yes, resistance. So mega ohm, I will write like this: 1 mega ohm. You have studied mega is 10 raised to 6. So 1 mega ohm is 10 raised to 6 ohm. Now kilometer, you are familiar with it, kilometer. So 1 kilometer equal to 10 raised to 3 meter. Now comes nanosecond. Second you have already know. Then millisecond is 1 by 1000th of a second. Microsecond is 1 by 1000th of a millisecond. And nanosecond is 1 by 1000th of a microsecond. So that much smaller unit of time. Or the rocket launching and the satellite installation, everything. Those space programs, all those space programs are measured in nanoseconds only. Because even if there is a slight deviation in the time measurement, the rocket will go in a different direction and we can't correct it thereafter. So all the measurements should be accurate to nanoseconds. Okay. So 1 nanosecond, I will write like this: ns, which is 10 raised to minus 9 seconds. And milliampere, you are familiar with milliampere. So 1 milliampere is equal to 10 raised to minus 3 ampere. So these are the certain examples. Now let us discuss what are some practical units for measuring small distance. When I was talking about the measurement of a book, I told you will measure it using millimeter and you can say it in centimeter. But I am asking you the thickness of your hair. Will you be able to measure using a scale? No. Can you express it using millimeter or centimeter? Yeah, obviously not. Because the thickness is very small that you cannot even use the units that we are commonly using. So millimeter and centimeter is of no use when we measure the thickness of hair or when we measure the thickness of paper. You have to go for some smaller unit. So let us see how to do all those things. The first one is Fermi. Before going to Fermi, since I was telling about the thickness of the paper and thickness of the hair, let me go to the last one, which is micron. Micron means micrometer. So the thickness of paper, hair, plastic, etc. will be expressed in micron. So I will write like this: 1 micrometer, 1 mu m. It is read as mu m. So 1 mu m equal to 10 raised to minus 6 meter. So it is used to express the thickness. Now we will go to the third one, nanometer. Even lesser than a micrometer. Where do we use nanometer? It is used to express the wavelength of light. Wavelength of light can be expressed in two terms, The first one is nanometer and second one is angstrom. These two units are used to express the wavelength of light. And 1 nanometer is 10 raised to minus 9 meter. And I told about angstrom also. Angstrom also is used to express the wavelength of light. And we write angstrom like this: 1 angstrom, capital A, and you put a 0 on the top of it. So 1 angstrom is 10 raised to minus 10 meter. We can measure the size of the atom also using nanometer or angstrom. Okay, so there are two uses. You can measure the wavelength of light using angstrom and nanometer, and you can also express the size of the atom using angstrom and nanometers. Now the last one is Fermi. Fermi is used for measuring the nuclear size. Nuclear size is much lesser than the size of the atom. When we compare the atom and the nucleus, the size is about 10 raised to 5 times. The size of the atom is about 10 raised to 5 times the size of the nucleus. That means 1 lakh times bigger than the nucleus is the atom. So if you consider nucleus as a cricket ball, the atom can be considered as a cricket stadium. That much difference is there. So we will write like this: 1 Fermi meter is equal to 10 raised to minus 15 meters. So these are the practical units for measuring small distance. Now let us see some practical units for measuring large distance. The first one is light year. Is light year a distance? Yes. Light year means it is the distance travelled by the light in 1 year. So what is 1 light year? 1 light year means it is the distance travelled by the light in 1 year. We use this measurement for finding the distance between Earth and any faraway star, or distance between two stars is measured in light years. So we can write like this: 1 light year. 1 light year, Ly, is equal to 9.46 into 10 raised to 15 meter. 10 raised to 15 meter. What is the speed of light in vacuum? In 1 second, the speed of light is 3 lakh. 3 lakh kilometer per second. Or we will say 3 into 10 raised to 8 meter per second. And in 1 year, the distance travelled by the light is 9.46 into 10 raised to 15 meter. Now the second one is astronomical unit. Astronomical unit means it is the average distance between the Earth and the Sun. Astronomical unit is the average distance between the Earth and the Sun. So we will write 1 AU. Astronomical unit is AU. 1 AU is equal to 1.5 into 10 raised to 11 meters. 1.5 into 10 raised to 11 meters. Now the last thing is Parsec. Parsec is the largest unit of measurement. So we have light year, astronomical unit, and Parsec. Parsec is the largest practical unit of distance. And 1 Parsec is 3.08 into 10 raised to 16 meter. 1 parsec is 3.08 into 10 raised to 16 meter. Or I can say it is 3.10 3.26 light years. 3.26 light years. Okay, so these are the practical units of length. Now let us move on to the practical unit of measuring large masses. Practical units of measuring large masses. The first one is ton. We can say either 1 ton or you can say metric ton. Both of them are same. So 1 ton is 1000 kilogram. 1 ton is equal to 1000 kilogram. Now comes quintal. 1 quintal is 100 kilogram. Then the third thing is pound. 1 pound is 0.45 kilogram. And the last one is Chandrasekhar limit. Chandrasekhar limit is the largest practical unit of mass. Chandrasekhar limit is the largest practical unit of mass. And we will write like this. We will write like this: 1 CSL, Chandrasekhar limit. 1 CSL is 1.4 times the mass of the sun. times the mass of the sun. Mass of the sun is around 2 into 10 raised to 30 kg. Two into 10 raised to 30 kg is the mass of the sun. So it is 1.4 times mass of the sun, and this is the largest practical unit of length. That's all for today. Thank you.